For years, the Tesla Model Y has quietly become one of the world's best-selling vehicles, electric or otherwise. It is the workhorse of Tesla's lineup, the car that shows up in suburban driveways, rideshare fleets and company car parks from California to China. But as competition intensifies and early adopters give way to cost-conscious mainstream buyers, Tesla's challenge is shifting. The company no longer just needs a desirable electric crossover. It needs one that wins on total cost of ownership, not just performance and tech. That is the context in which the next major update to the Model Y, widely known by its internal code name, Juniper, is being developed, and why its most important changes may be the ones you barely notice. Unlike the dramatic styling tweaks and interior overhaul that accompanied the Model 3 Highland refresh, the Model Y Juniper project is expected to focus as much on hidden efficiency and cost-cutting as on visible design changes. Official details are scarce. Tesla has not publicly presented a Juniper prototype or announced a launch date. But based on the company's pattern with previous refreshes, supply chain leaks, and regulatory filings in key markets, a picture is emerging of a crossover that uses dozens of small hardware and software revisions to reduce energy consumption, extend component life, and chip away at the day-to-day expenses that owners actually feel. Under pressure from Chinese rivals who are pushing out aggressively priced electric SUVs, and from regulators tightening efficiency and emissions rules, Tesla is in a new phase, chasing incremental gains. The days when a new Tesla meant a massive leap in range or world-beating acceleration are giving way to an era where a few percent here in aerodynamics, a few percent there in drivetrain efficiency and thermal management add up to real money over years of driving. For a typical owner, the biggest recurring bill associated with a Model Y is energy. Electricity is cheaper per mile than gasoline almost everywhere, but it is not free, and in some markets it is rising fast. The second major bill is maintenance. Tires, brakes, suspension, HVAC components, unexpected repairs. Insurance and depreciation make up the rest of the financial picture. Juniper is being shaped to bend all of those curves downwards. It is not about a single headline feature that slashes costs overnight. It is about stacking many subtle improvements that quietly lower bills over time. One of the simplest ways to reduce an EV's running costs is to make it slip through the air more easily. Aerodynamic drag rises roughly with the square of speed, which means that at highway speeds, a large chunk of the energy your battery expends is just pushing air aside. The current Model Y already benefits from a relatively low drag coefficient for a crossover, but the Juniper refresh is expected to go further, taking lessons learned from the Model 3 Highland's reshaped nose, new headlights and revised underbody panels. Changes visible to the casual observer, slightly smoother bumpers, reprofiled front fascia, revised rear diffuser, new wheel designs with more effective aero covers, are likely to be more than cosmetic. They may trim a few points off the drag coefficient, enough to add several kilometers of real-world range, or to slightly lower energy consumption at a steady 110 km/h. That might not sound like much, but for a driver who does tens of thousands of highway kilometers per year, a 4 or 5% reduction in consumption can mean hundreds of dollars in saved electricity over the life of the car. Subtler exterior tweaks may also contribute. More efficient side mirror designs, tighter body panel gaps, improved underbody shielding, and even a small spoiler lip at the rear can all nudge airflow in the right direction. Combined with potential weight savings from new materials or casting strategies, the result is a Model Y that needs fewer watt-hours to travel the same distance. On a spec sheet, this might translate into a modest bump in rated range. On a monthly utility bill, it shows up as a slightly smaller number every time the owner checks their home charger's energy log. Beneath the sheet metal, the powertrain, motors, inverters, and gearboxes offers another avenue for incremental cost savings. Tesla has spent a decade refining permanent magnet motors and silicon-based inverters, and any Juniper update is likely to include further tweaks aimed squarely at efficiency in the real driving regimes where owners spend most of their time. That means optimizing for moderate acceleration and steady cruising, not just headline 0-100 km/h times. One expectation is that Tesla will migrate more Model Y variants to its latest generation of drive units and power electronics, similar to those that have quietly rolled out in other models. That could mean improved motor winding designs, lower loss bearings, and redesigned inverters with a more efficient mix of silicon carbide and conventional silicon switches. These components do the invisible work of turning battery DC energy into the AC power that spins the wheels. Every fraction of a percent shaved from conversion losses is energy that remains available for propulsion rather than wasted as heat. Gearing, too, can be adjusted. Tesla has historically chosen gear ratios that balance brisk acceleration with highway efficiency. As the market matures and fewer buyers care about sports car-level sprints, Juniper could tilt slightly more toward energy saving, lengthening effective gearing to keep motor RPMs lower at cruising speed. Software also plays a role. Refined control algorithms can manage how torque is split between front and rear motors in dual-motor variants, favoring the more efficient axle under light loads, and only calling for full dual-motor power when needed. Over long commutes, these unseen decisions cumulatively reduce how much electricity owners buy. Thermal management is another area where small improvements can have surprisingly large financial impact, particularly in regions with very hot summers or cold winters. The Model Y was among the first Teslas to adopt a heat pump and the octavalve thermal architecture, letting the car shuffle heat between cabin, battery, and drivetrain far more intelligently than earlier resistive heater setups. Juniper is expected to refine this system further, borrowing both hardware and control logic advances first seen in newer models. Sharper control of refrigerant flow, more efficient compressors, and smarter use of waste heat can cut the energy needed to heat or cool the cabin while maintaining comfort. Cabin preconditioning, heating or cooling the interior while the car is still plugged in, could be made more aggressive and more predictive, using learned driver habits and weather forecasts to get the timing right. Better insulation and multi-layer glass, which Tesla introduced on the Model 3 Highland and has been gradually extending across its range, reduce how hard the climate system has to work to maintain a stable temperature. For owners in extreme climates, a double-digit percentage drop in HVAC energy use is realistic, which again directly reduces the size of the monthly electricity bill. Battery preconditioning, the process of warming or cooling the pack before fast charging, is another target. Done badly, it can waste energy. Done well, it shortens fast charging sessions and improves pack longevity. Juniper's software is likely to refine when and how intensely the battery is preconditioned based on charger type, route, and pack state of charge. Over hundreds of DC fast charge events that can trim total energy overhead and, more importantly, reduce stress on the cells, helping to preserve range and performance for years, delaying the onset of degradation-related range loss that can erode resale value. The battery pack itself is poised for evolution. Tesla has multiple cell chemistries in play, cells for long range and performance trims, and lithium iron phosphate LFP, for standard range models in some markets. For Juniper, the company is expected to integrate its latest revisions of these chemistries, which promise slightly higher energy density and lower internal resistance without major cost increases. That means more usable energy in the same pack size, slightly faster charging, less heat generated under load, and marginally better efficiency. There is also the question of pack architecture. In some regions, the Model Y already uses a structural battery pack, where the cells are integrated into the car's body as a load-bearing element between front and rear castings. Juniper is likely to standardize or expand this approach, which can reduce weight and parts count. Less mass means less rolling and inertial energy to overcome at every acceleration, trimming energy use in stop and go traffic where many owners spend most of their time. Structurally integrated packs can also improve stiffness, which allows finer suspension tuning that, in turn, reduces uneven tire wear, less obvious on a spec sheet, but important for the tire replacement bill. A critical but often overlooked part of EV cost of ownership is charging speed and curve behavior. If Juniper's pack and power electronics accept higher peak charging rates for longer at fast charging stations, owners spend less time plugged in on road trips, but the hidden financial impact is in network usage fees and opportunity cost. For owners who pay by the minute rather than per kilowatt hour, faster sessions translate directly into lower fast charging bills. Even for per kWh pricing, a healthier thermal and electrochemical profile can reduce the overhead energy used for pack management during charging, shaving a few percent off total energy drawn from the grid per trip. Software is where Tesla has historically differentiated itself, and Juniper is expected to double down on software-driven savings. The company has already shown how over-the-air updates can improve range and performance on existing vehicles through revised inverter control, better motor torque maps, and smarter thermal strategies. A refreshed Model Y will likely ship with an even more integrated efficiency-oriented software stack, aided by newer onboard computers and, in many markets, Tesla's latest autopilot hardware. Smarter energy prediction in the navigation system can route drivers more efficiently, favoring roads and speeds that minimize energy use when arrival time allows. Enhanced eco-driving modes might slightly soften throttle response and cap peak power in exchange for noticeable gains in range, giving owners the option to prioritize low bills over performance on a daily basis. More transparent energy dashboards, showing breakdowns of consumption by HVAC, driving style and accessories, can nudge driver behavior, encouraging habits that extend tire and brake life and keep electricity usage down. One underappreciated source of ongoing cost is vampire drain, the slow trickle of energy an EV consumes while parked, maintaining communications, thermal stability, and security features. Tesla has already reduced vampire drain significantly over early years, but Juniper's newer electronics and low-power chips could drop it further. For urban owners who do not have convenient overnight home charging, losing fewer kilometers of rated range every day the car sits parked in a public lot reduces the number of paid charging sessions needed just to keep the battery topped up. Beyond energy, Juniper's hidden upgrades are expected to attack maintenance-related bills. The suspension is a good example. Tesla constantly refines bushings, dampers, and geometry as it learns from warranty data and customer feedback. A refreshed Model Y will likely use components tuned for both comfort and durability over imperfect roads. Better matched dampers and stronger, more fatigue-resistant control arm designs help the car maintain proper alignment longer, which directly impacts tire wear. For owners, That can be the difference between needing new tires at, say, 30,000 kilometers versus 40,000 or more, a substantial cost over multiple sets. Braking systems also evolve. While EVs rely heavily on regenerative braking, the friction brakes are still critical in emergencies and in certain driving conditions. Juniper may adopt revised calipers, rotors and pad compounds optimized to resist corrosion and uneven wear, issues that can plague EVs whose friction brakes are used infrequently. Longer-lasting brake components mean fewer service visits and lower parts bills, especially in climates where road salt and moisture are common. Combined with updated brake control software that periodically exercises the friction system to keep it clean, the effect is to turn one more potential source of surprise expense into a largely invisible, well-managed subsystem. Inside the car, some of the changes rumored for Juniper, new materials, simplified dash design, possibly ventilated seats and more efficient seat heaters, have a direct or indirect impact on bills. More durable interior textiles and trim reduce the likelihood of expensive out-of-warranty repairs or cosmetic issues that hurt resale value. Efficient, targeted seat heating and ventilation allow drivers to rely less on whole cabin climate control, which is more energy hungry. A driver who uses heated seats and steering wheel instead of raising cabin temperature by several degrees can dramatically cut HVAC draw on cold days, extending range and reducing energy costs. Tesla's ongoing shift in low-voltage electrical architecture could also touch the Model Y refresh. The Cybertruck introduced 48-volt systems for many onboard electronics, reducing current and allowing lighter, thinner wiring. If elements of this architecture migrate into Juniper, whether fully or partially, it would cut copper usage, trim vehicle weight, and slightly reduce power losses in the wiring harness. Even small wattage savings in always-on systems add up over thousands of hours of operation, trimming the background energy consumption that owners pay for but never see directly. Tires, often the single biggest non-energy running cost on an EV, are another quiet frontier. The Model Y is relatively heavy and torquey, traits that can accelerate tire wear. For Juniper, Tesla and its tire suppliers are likely to refine compounds and tread patterns for lower rolling resistance and better longevity, while still meeting safety and handling targets. A percentage point or two reduced rolling resistance can save meaningful energy at highway speeds. Meanwhile, more durable sidewalls and optimized contact patch design can stretch the interval between replacements. Better factory alignment specifications and more precise assembly, made possible by incremental improvements in the production line, further support even tire wear. Over 150,000 kilometers of ownership, the difference between 3 and 4 sets of tires is a non-trivial line item in a family's budget. All of these changes play into a broader strategic goal, making the Model Y not just competitive on sticker price, but compelling on total cost of ownership when compared to rival EVs and even efficient gasoline SUVs. Mainstream buyers running spreadsheets now weigh fuel savings, maintenance, insurance, and depreciation closely. A refreshed Model Y that uses 5 to 10% less energy per kilometer, asks for fewer consumables, and maintains higher residual value thanks to durability and perceived modernity, can justify a slightly higher upfront price, or allow Tesla to protect margins in the face of price wars. At the same time, many of Juniper's hidden upgrades are likely to reduce Tesla's own manufacturing costs. Wider use of gigacast front and rear structures, more standardized structural battery packs, simplified interiors, and a consolidated wiring harness all lower the number of parts and assembly steps. A cheaper-to-build Model Y gives Tesla room to pass some savings on to buyers, further improving the ownership equation. And because many of the efficiency-boosting enhancements, better aero, improved motors, smarter software, also improve the driving experience with quieter cabins and smoother performance, there is less sense of compromise for the customer. The stakes are high. In markets like Europe and China, new entrants are offering aggressively priced electric crossovers with long feature lists, while legacy automakers are finally fielding credible alternatives to Tesla's vehicles. A half-step refresh that only updates the look of the Model Y would not be enough. By contrast, a Juniper update that meaningfully lowers lifetime energy and maintenance costs can reassert the Model Y's position as the rational financial choice, not just the trendy tech option. For existing Model Y owners, the prospect of Juniper may raise concerns about obsolescence. But Tesla's heavy reliance on software means that some of the efficiency and feature gains developed for the refresh will almost certainly be backported, where hardware allows, through over-the-air updates. That softens the transition and helps preserve used values. At the same time, hardware-level upgrades in Juniper, new motors, better thermal hardware, refined suspension, will give the refreshed cars a quiet advantage in the used market years down the line, as buyers grow more aware of the importance of efficiency and durability in second-hand EVs. Ultimately, the Model Y Juniper story is not about a radical reinvention of Tesla's crossover. It is about a maturation process. Early electric vehicles won hearts and headlines with shockingly quick acceleration and futuristic tech. The next phase is more prosaic, but just as important, making EVs that are relentlessly optimized for low running costs, reliability, and long-term value. In that world, a slightly slipperier body, a more judicious heat pump, a less power-hungry electronic suite, and a more durable suspension are not footnotes. They are the core of the product proposition. If Tesla executes on Juniper the way it did with the Model 3 Highland, focusing on structural simplification, comfort, efficiency, and quality, it will deliver a Model Y that looks only subtly different but behaves very differently in the life cycle cost spreadsheet. For owners, the effect will be felt not in a single dramatic moment, but slowly, as monthly energy bills edge lower than expected, as tires and brakes last a little longer, as unplanned service visits remain rare, and as resale values hold up. That is how a series of small changes, many of them hidden from obvious view, can end bills over time far more effectively than any flashy new feature ever could.